After draining nearly all of my GPU runtime on Kaggle, it's finally here. The easy-to-use free RVC notebook. It's the app which lets you replace the voice in your favorite song with yourself, another singer, an anime princess, or just about anything. RVC also works great for simply changing the voice in spoken text. We'll take a song and a voice sample, then blend them together to create something unique. To get started, head over to the link in the description and fire up your own copy of the RVC notebook. Don't forget to sign into Kaggle and ensure you've got a GPU accelerator, an internet connection, and file persistence switched on. Once you're set up, hit that Run button next to the first code block to kick off the installation process. Installation usually takes about 4 minutes. While we wait, I'll go grab a royalty-free song to use as an example. To replace the vocals, I took a 10-minute AI voice recording. A real voice would make the result more natural, but we'll keep it synthetic for the first run. If you've got your own voice recordings, even better. And don't worry if you don't have any. We'll explore some awesome models on Hugging Face later in the video. There's a handy code block for downloading MP3 files from the web. But since I'll also be adding an AI text sample, I'll use the file browser for both. Simply start the file browser code block. Follow the Remote Mo link to the web UI. Enter admin and admin if it asks for a password, and navigate to a folder where you'd like to upload your files. I'll create an input folder for the voice recording. There should be one separate folder for each voice, and I'll put the MP3 file in my song folder. I like to delete any spaces and odd characters in the MP3 file name to avoid potential errors. Once your files are uploaded, it's time to extract the vocals and instrumental tracks. Just enter the path to your uploaded MP3 file in the UVR file variable. The path can be easily found by clicking the copy path icon in the file browser on the right. Then hit Run, and when the code executes, you'll find the separate tracks in the opt folder. You can also use this code block to remove background noise from a voice recording. Now, let's move on to replacing those vocals with our sample voice. Run the web UI step and wait for the line that says the app is running on a local URL. Then click the Remote Mo link to open the web UI and head over to the Training tab. Here we can turn our sample recording into a model which can be used to generate a clone of that voice. Simply give your model a name, paste the path to your audio recording, and let the training begin. You can view the training progress in the notebook. Once your model is ready, hop over to the Inference tab. Click the Refresh Models button, and the new voice will show up in the Model drop-down menu. With the model selected, let's fill in the path to the audio track to be replaced. We'll select the vocals we extracted from the MP3 song earlier. Now click Infer to kick off the generation process. The synthetic vocal will be saved in the Outputs folder, and we can listen to it in the audio player. Here's a quick comparison with the original vocal.
I don't understand a single thing you've been saying. Nothing seems to make any sense at all.
I don't understand a single thing you've been saying. Nothing seems to make any sense at all.
Now that you've got your new vocal track, it's time to merge it with the instrumental track using your favorite audio editing app. To download the track, grab it from the Outputs folder, either in the Kaggle interface or by starting the file browser. We've got a step here that merges the vocal and instrumental tracks using FFmpeg, but be warned, it can be resource-intensive and might crash your runtime. So, make sure to download your work before giving it a spin. If the merge is successful, the output will be in the Audio Out folder. Speaking of saving our work, where is that model anyway? We need two files if we want to share our models, the path file and the index file. These are in the checkpoints folder, with the index file being in a separate folder, named after the model. We can use the checkpoints folder to upload other models as well. For example, a model we just unzipped from Hugging Face. The model is called EtherJP, so I'll put the path file in the checkpoints folder, create a folder called etherjp_index, then put the index file in there. There's a convenient code block below that puts the files in the correct location, as long as we have both links. Let's go find an unzipped model on Hugging Face and give it a go. This one looks perfect. I'll copy the links and paste them to the notebook. Let's give it an appropriate name and let the notebook download everything. To test it works, I'll run the web UI again, and this time select the SpongeBob model. I'll use the same audio track from the previous example.
I don't understand a single thing.
With the generation done, I'll run the final step of combining it with the background track. And here's what we got. I won't play much of it here as this is not my voice, but the meme potential is definitely there. If you're out of GPU time on Kaggle, a tutorial on running this in SageMaker Studio Lab will be linked right here. As always, thanks for watching and happy generating.